Now, we're looking at practice exercise 3, implementing stacks. Well, this is this old style way. If you look at an iStack, I'm going to redo this namespace to not have the curlies, but instead have this. I need a semicolon at the end of that. Okay, so you can push to a stack, you can pop from a stack, you can peek, check if it's empty and see the length or the size. I decided to go with length. I don't know if there are other names that people conventionally use. You see in the stack? Yep. The shift and tab goes backwards. Is that what you're saying? It's like an untab. There's also, if you do Command Shift P, and then type in format document, it'll re-tabify everything. Okay. Oh, thank you. Slash ouch.
That's just more about how useful it is than how
okay. I'm going to come into stack CS and create namespace, not namespace, yes, namespace, practice exercise 3, semicolon, to say that stack is going to be in the practice exercise 3 namespace. Okay? So we got that. And I would like to create a public class stack that's generic in T that implements iStack that's generic in T. So remember, when you implement an interface using this interface, this syntax, colon, interface name, you're saying to the compiler, I promise to give bodies to all of those methods that are listed in the interface that don't have bodies. They're just the parameter signature, the method signature. And that's why now the compiler's mad at us. It's saying, you said you were an iStack. You have lied to me because you don't have a push, pop, peek, is empty, or length. And they have to exactly match this interface. You've got to have a length that is read-only and that returns an integer. And you got to have a push that takes a T and is void and all that. So I'm going to say quick fix and implement interface. When I do this, it at least creates all those signatures correctly, but throws not implemented exception. So we can fix that, but at least this will compile now. So my idea in this is to use a linked list. I hope this isn't disheartening to you, but Microsoft already wrote a really good linked list. I want to use it. I do not want to use your code from the previous practice exercise. No offense. So I'm going to create a private linked list that's generic in T. I'm going to call it linked list. And I'm going to go ahead and instantiate it to a new linked list of T. So this linked list, you can see it if you hover over it. Can you? If I hover over that. You see where it's coming from? It's coming from system.collections.generic. So this tells me that is the linked list that Microsoft wrote. I would like to use that because I know that's a really good linked list and it's going to be high performance and debugged. So what I'd like to do for this stack is exactly what I wrote on the board. Implement a stack with a linked list. We do get this decision that we need to keep in mind. Is the top of the stack at the front of the linked list or the back of the linked list? And you can do it either way. You just have to be consistent. Do y'all have a preference as to where to put the front, where to put the top of the stack? You see what I mean? You can put it at the end of the linked list and say this is the top. We add and remove here. Or it could be here. We can add and remove at the beginning. The left, the front. Any objections? What's that? We're going to prepend when we push. So let's go ahead and do that since we're thinking about it. So when we push, coming down to push here, I'm just going to say linked list dot prepend whichever item we just got. That we have just now pushed. We pushed by putting it at the beginning. So the beginning of the linked list, the head, is the top of the stack. Okay? We're not dealing with indices. And also, we're not implementing the linked list. So the linked list is in charge of keeping up with its own size. We've completely offloaded it to Microsoft. Isn't that nice? Now, we do have to say what the length of our stack is. So let's try to figure that out. If I say linked list dot, I'm pretty sure there's going to be a size or a length. I can't remember it. Count. Thank you. Count the number of nodes actually contained in the linked list. Is that stored or computed? Answer is, we have no idea, and we don't care. Microsoft wrote it. Huh? I'm sure it's good. You know, I just want to say, we can't know because we can't see inside their code, unless they've open sourced it. But this is what we want to do, right? The length of our stack is the number of things in the linked list. How about this? How do we know if our stack is empty? If the length equals 0, which I can do really concisely as this one-liner arrow function. Yeah? If it's 0, it's empty. If it's not 0, it's not empty. So there's that. We are 3/5 done. That's 60%. Okay, this is essential. How do we pop? The way that we pop is bound to the way that we push. Because it's a stack and we need to remove the top. Where's the top? Front of the linked list, back of the linked list. Front. Okay, so we want to remove the front. Let's see how to do that. So part of this is learning Microsoft's methods. If I type in RE, I see that there's a remove first, and a remove last. One of those sounds very useful to me. Remove first. And let's just read the documentation. Removes the node at the start of the linked list NT. Yep, that is what I would like. It's a method. Let me hover over it. When I remove it, though, it doesn't return anything. Pop does need to return it. So I need to return the thing that was at the front of the linked list. So I better save it first. So I'm going to say var top, I don't know, top of stack is equal to linked list. And I would think that they have a first. They do. So first gets the first node in the linked list. Notice it's a node, and that is, they use the same kind of naming as us, linked list node generic NT. So let's see what this looks like. I'm going to say dot. Their node has a list property, which actually points to the list that it's in. It has a next pointer. It has a previous pointer. It has a value. And it has a reference to the value held by the node. And it's a string and all those other normal things, equals against hash code. The fact that it has a next and a previous tells us something about the linked list. What does it tell us about the linked list that this came out of? It's a doubly linked list. What I really want here, though, is the value. So I want the value of the first. And then I want to return the top of stack. Because I guess if I could, I'm going to make this T, okay? I mean, that's what it will be inferred as. But I need to return a t. This would be, if this is a stack of integers, then t would be int. If this is a stack of student objects, then t would be student. So I'm going to save the first one. I'm going to remove the first one, and then remove the one that I kind of saved a reference to. Note, and I don't even save the whole node. I just have a reference to the data that's inside of it. Okay? I just want the integer to return, not the whole next. Yep. Which one? This? Here? This? Wait, you mean like that? My private linked list? Okay, there is a bit of an error here, which is, what if the list is empty? Or what if the stack is empty? That's no good, right? So if is empty, if the stack is empty, then I think what I want you to do, because I saw it in here, is to throw an empty stack exception. You see this guy? So I want to throw a new empty stack exception because you can't pop if there's nothing in the list, in the stack. Well, the list and the stack are going to be both empty, right? Because they map to each other. Okay, we got 2 minutes, and guess what? We can finish this thing. How do you peek? Peeking is almost just like popping. Yes? What's the difference? You just look at it. You don't actually remove anything. So if you copy paste pop and then remove the remove, you with me? I still want to, you still can't peek if it's empty. If it's not empty, then you get the first one's value and return that. But you don't remove it from the stack. Does that make sense? So I think we're done with stack. You feeling this? Like this was dog water. You guys could have done so much more than this. So what I'm going to invite y'all to do for practice exercise 3 is implement a queue and implement a deck. So a queue is basically defined in IQ. It's the smartest of the interfaces. Because it's IQ. Anyone? Anyone? No? Thanks, Caleb. So again, NQ, DQ, first, last. I went with first and last instead of front and back. And then linked and is empty. And then in IDEC, there's add front, add back, remove back, is empty, length, front and back. These are all really straightforward, and you get to build on top of Microsoft's linked list, which may mean you've got to like explore and see what the methods that they give you are, but they give you all the methods that make it really easy. Did you see how easy this was? So that's why I made this due on Saturday. We can knock this out. I'm pretty confident you could do this in 30 minutes. Let me know if you have issues. I think I may need to update a unit test, so I'll do that and send that out to you. Code hard, be strong. Thanks for stacking with me today. Hey guys, this is me coming back after class to correct a really big error that I made. I started testing this and realized that nothing was working, and nothing was working because of this line of code. This prepend function is not the function we want. It does not do what you would think it would do. It's not one of the operations on a linked list. So in order to push our item onto the beginning of our linked list, we don't want this line. Instead, we want to say linked list dot add first. So add first, you see, is a method that's defined on the linked list class, and it adds the specified new node or new value at the beginning of the linked list. So when I say add first, I can pass in the item like I did before, And now this method, add first, will actually add a new item and a new node at the beginning of the linked list. Prepend did not do that. That was a bug that snuck up and got me, and it breaks in an unexpected way because it looks like it would do prepending, but that's not what we want. So I wanted to make sure to put that correction out there because it is so bad and it makes the whole program not work because nothing ever gets added to the stack. So use linked list.add first, not prepend. Thanks, guys.